Today is February 28th, 2013. We're in Santa Ana, California at the headquarters of PureAqua, and we wanted to use two recently manufactured reverse osmosis systems to go over some general guidelines about system selection, installation, and system startup. First of all, the system is selected based upon primarily the analysis of the feed water, where the feed water is coming from, how much water one wants to produce, product water that is, and then just what quality of water they want the product to be. In this instance, we have two examples. This system here is a skid-mounted system, and it includes a number of pre-treatment appliances. Specifically, we have a multimedia filter, which has sand, anthracite, and gravel in it, and it's used for removing particulate ahead of the reverse osmosis. Secondly, we have an activated carbon filter. It's used for some organic removal as well as taste and odor. And then we're going to be injecting anti-scalant, which will keep the membranes from scaling as a result of hardness in the feed water. Another option is a water softener. For one reason or another, people sometimes choose the water softener and sometimes the anti-scalant. But in most cases with naturally occurring water, you will need to be sure you control scale, or you'll have a problem with membrane scaling, reverse osmosis membrane scaling. Next, we want to talk about installation. Once you've received the equipment and it's on site, it's important that you use qualified installation people, specifically a plumber and certainly an electrician. You'll have to plumb water, or you'll have to bring water to the system, take water away. There are drain fixtures to be concerned with, and then of course you're going to have to supply power. I mentioned having a qualified plumber and electrician for installation. Specifically on the plumbing, you'll have a raw water inlet, which is right here at the first valve, and then you're going to have, in this case, you're going to have three outlets. You'll have, four outlets, three to the drain. One, you'll need a drain for the backwash on the multimedia filter. You'll need a drain line for the backwash on the activated carbon filter. You'll need a drain line for the RO reject. And then you will also, and of course you'll have the RO product exit. So you'll have four lines exiting this equipment, one of which is your product water, which should go to a tank at atmosphere. Quite oftentimes people use a level control switch in conjunction with a product tank, whereby you have a float, and you can use that float to start or stop your RO system. Where the electricity is concerned, you need to be absolutely certain that you know the voltage requirement of the equipment. It should be on your sales order, it should be on your instructions, it should even be labeled on the RO control panel. In this instance, with a skid-mounted system, in most cases you supply one power to the RO control panel, and subsequent from that, all these other appliances will be powered. And then of course you want to make sure that that's done by a qualified electrician, and the connection is inside the controller here. You'll feed the power up from the bottom in most cases, connect it to the appropriate connections, and then once the power is connected and the power is onto the system, you never want to open this panel unless you're a qualified electrician or you've made sure that there's no power to the panel. The panel, just because the RO system is off, there is still power, live power inside the panel. And so you shouldn't have to open this at any time unless, like I say, you're a qualified electrician, maybe doing some diagnostics, or you've made sure the power to the panel is cut off before you were to go in and handle any of the wiring. Stop. We're looking at the back of the same reverse osmosis skid right now, and we wanted to highlight where some of these plumbing connections are. This is your raw water coming in, and this is your multimedia filter, activated carbon filter, and then reverse osmosis. These lines here off the multimedia filter and the activated carbon filter should be directed to a drain, however far that is. So normally when you receive this in a skid-mounted system, you'll see this tubing down to maybe the bottom of the frame here, and then you'll have to connect to that and go to a drain. The reverse osmosis reject exits the back of the control panel at the top of the reject flow meter. And in this case, it's a male NPT threaded connection, and you'll run from there again to a drain. The RO product is also coming off the back of the RO control panel at the top of the product flow meter, and you'll want to direct that flow to a product tank at atmosphere. Okay, assuming you have the plumbing and the electrical completed, you now need to look at some pre-start checklist. You want to make sure that you've backwashed the multimedia filter and the carbon filter for at least 2 cycles, or at least twice, to make sure there isn't any debris. And when you're doing that, you don't want the feed line from the activated carbon filter to be connected to the RO. You'll disconnect that and run that to drain 2, because even during backwash, you'll have some feed water past these filters, and it could get into the RO before we've finished cleaning these filters. Once you've done the backwash on these filters and the water coming through looks to be clear and clean, you'll connect the feed line from the activated carbon filter to the RO inlet and prepare to start up the reverse osmosis system. You basically have, in this instance, you have 3 valves to be concerned with. You have a valve that's just off the pump exit, and it's used to throttle the pump flow to get the right combination of flow and pressure. If you can't maintain a minimum pressure of 20 psi, or actually 15 to 20 psi to this RO system, it will shut down automatically for what's called a pressure fault. And we'll probably talk about that a little bit later. But anyway, you've got the valve coming off the pump, you have a reject valve, and you have what's called a recirculation valve. Not all systems have a recirculation valve. Generally, just smaller systems with maybe 2 or 3 or 4 membranes will use recirculation. But for the sake of startup, we want to close this valve completely. And then lastly, we want to open the reject valve completely. So we have 3 valves. We have the pump coming off the valve coming off the pump. Generally, it's a valve with a handle on it, and you want the handle to be at approximately 45 degrees. If the system's been tested at the factory, that valve is probably already in the proper position, but since the system's been shipped, that valve could have changed position. So it's probably not a bad idea to start at about a 45-degree angle for that valve coming off of the pump. Completely close the recirculation valve, completely open the reject valve. Now we've pretty much gone through each of the components here, and we're ready for startup. You've got water that's plumbed to the system. You've got electricity that's been connected to power the system. You've flushed the filters. Your anti-scalant solution is prepared. You've set the dosing pump. You've connected the feed to the RO. You've got the valve after the pump, the handle of the valve at about a 45-degree angle. Your recirculation valve is closed. Your reject valve is open. At that point, we can press the power or the on button, on or off button. It's the power button on the RO control panel. And the system or the pump will start after anywhere from 5 to 15 seconds, depending on the delay. Actually, there's an inlet solenoid that opens right away, lets feed into the system. It gives the delay, the pump delay, gives that feed coming in a little bit of time to fill the system. Now, when we first start up, as I said, the solenoid valve will open, water will come in, and a few seconds later, the motor will start and the pump will start. And we'll want to let it run a little bit like that, just to get most of the air out of the system. You can see air in these flow meters, especially when you first start up. And when most of that air is gone or has dissipated, then we can begin to start to close the reject valve. Before we start to close the reject valve, almost all of the flow through the system should be coming through as reject, and you'll have very little product. As we begin to close this valve, the reject will begin to drop in terms of quantity or flow, and the flow to the product will start, because this valve is located at the very end of the system, and as I close it, I'm going to force water through the membranes and not let it go to the drain, or at least not as much water. At the same time, I'm going to see the system pressure increase as I close this valve. Again, because I'm closing the end of the system, the orifice is becoming smaller, water is being forced through the membranes. And your membrane or your manual should tell you a target pressure as well as target flows for your product and flow, for your product and your reject. And then the last adjustment, once you have everything pretty much where the manual tells you you should be, you can begin to open the recirculation valve. And in doing so, you'll take some of the water that was previously gone to the drain, and you will refeed it back to the, you'll actually send it back to the feed to the pump, and it will become feed to the pump, and then you will have less reject. You'll see, as you open this valve, you'll actually see the reject flow drop. And again, your manual should give you some guidance as to how much to open this based upon what your readings are on the flow meter. Previously, we've been talking about this skid-mounted system for the sake of this demonstration, but I also want to mention that we have a lot of customers that just buy the RO system by itself, and they may buy pre-treatment appliances, but they're not always skid-mounted like on this first system here. Here is a reverse osmosis system, very similar to the one we've been talking about, with some unimportant differences. But one thing that's important to understand is that almost all reverse osmosis systems require some kind of pre-treatment. Rarely is it possible to use reverse osmosis without either using a filter to remove particulate, a softener maybe to remove hardness, or some kind of ion exchange, or anti-scalant injection. In the case of the skid-mounted, everything was powered at the RO controller. That can be the case in a system that's sold like this. In a lot of cases, the appliances are powered separately, individually, but they're almost always connected in some sense to this RO control panel, so that when a filter goes into backwash or a softener goes into regeneration, the RO system is told by way of the controller.